Okay. So looking at this one, x squared plus y squared equals 1, so we know the center is 0, 0, and the radius is 1. So plot your point at 0, 0, go 1 to the right, 1 to the left, up 1, down 1, draw your circle, and mark your radius here. Now that's pretty little, isn't it? So that's why I decided I'd label my vertex of the center. I'm sorry, not the vertex, but the center. I decided I'd label it out here and draw an arrow. Just too crowded in there, you know? So that's okay if you want to do it that way. Any questions on that? Okay, let's look at this next one. So if we have this equation right here, if I can get it to focus, it would be a nice thing. There it goes. We know the center is going to be 0, 0 again, right? How do I figure out what the radius is of that? Somebody explain how. Look at a previous problem. See if you can figure out how to find the radius of that. It's not just that number there, right? Yes, that's exactly right. You take the square root of that. Y'all put that in your calculator. Take the square root of 6.25. Connor, we're in the notes packet.
Okay.
2.5, okay? So you're going to take the square root of 6.25 to get the radius. And we get 2.5, which is 2.5, right? So y'all graph it. So you plot your center 0, 0. Your radius is 2.5. So you need to go over 2 and then half. So right in the center between these 2 points, put a little point. Do the same thing here. 1, 2, and then a half. 1, 2, up, and then a half down. 1, 2, and a half. Then draw your circle. Again, draw your radius and label it. Oh, it doesn't matter if you label it 2.5 or 2.5. That part doesn't matter, does it? Do it decimal. It's easier to write a decimal when you don't have much space. Any questions on that one? Are we good with this? This shouldn't be too hard. Okay, now we're going to do ellipses. Ford, you need to get your note packet out. You need to be working on math, not history. The general equation of an ellipse. That's the top of the next page. Now the first thing I want you to notice is the difference between this and the equation of a circle. Well, at the same time that we look at the difference, we can also be looking for similarities. Like this part right here and this part right here looks like the equation of a circle, doesn't it? But these underneath here do not, do they? Also, this isn't saying that it's r squared, it's saying it's 1. That means it's always 1. It's always going to be a 1 right here. So that means if it's not a 1, we got to make it a 1. That's really what that means. So let's go through this. The center is going to be HK, so that follows along with the same as with a circle. A is the length of half of the horizontal axis, and B is the length of half of the vertical axis. And when we get ready to graph it, that'll make more sense to you if that's not clear. Let's go back to what the differences are. It says, well, how is this different from the equation of a circle? Well, one of the things we said was that it's equal to 1. Always. If the radius of a circle is 1, it would be equal to 1, but that's the only case, right? The second thing is, you have an a squared and a b squared in the denominators. We don't have those at all on a circle, right? And talking about equal to 1, well, there's not a radius. There's not a radius with an ellipse. There's a radius with a circle, but there's not a radius with an ellipse. Any questions on that part? Okay, and we talked about a similarity is that HK is the center. So that x minus h squared and that y minus k squared, that's what's similar, which means that HK is the center. So let me give you an equation here and we'll graph it, okay? So we're going to graph x minus 1 squared over 4 plus y plus 2 squared over 9 equal to 1. Good morning, Julia. We're in the note packet on the page that starts off saying general equation of an ellipse. So what we want to do is we want to identify the center. Can anyone tell me what the center of this ellipse is going to be? Positive 1 is correct. What's the other one? Negative 2. Okay, positive 1, negative 2. So let's go ahead and plot that point. So 1, negative 2. We're going to plot that point. Now, we need to look at this a little careful here. In the general equation at the top of your page, it says that this number underneath the x squared is a squared, right? So that means that a squared is equal to 4. So a is equal to 2, right? If a squared is 4, then a is 2. Uh-oh. Don't know what just happened there. There it goes. So what we're going to do is, it says that a is half the length of the horizontal axis, because it's half of it because we're going to go 2 to the right and 2 to the left. So that makes it half, right? That's the half part. So the whole length of that would be 4. Does anyone understand what I mean by that? Okay. So the 9 is b squared. So if b squared is 9, then b is 3. So from the center, we're going to go up 3 and down 3. So getting those points is very much like a circle, but it's not a radius. It's different depending on if you're talking the x direction or the y direction, the horizontal or the vertical. Does everybody get that? Okay, now we're going to just graph it. You usually do a better job with these if you do like top and bottom so that the, it looks like a curve. I don't want it to look like a point at any of these things. We will label the center when you're finished. And then you want to label at least one of the points that you made right or left. I don't care which one, because they should be symmetrical to each other. In other words, this one's 2 this way, and this one is 2 that way. So I'll just label this one 1, 2, 3, 1, 2. So 3, negative 2. And then label one of the points that you graphed vertically. So I can either label that one or label that one. So I'll just label this one. It's 1, 1. But you make sure that you have the same distance to the center from each of these and then to the center from each of those. Any questions on that one? So it is sort of like a circle, right? Okay. So turn to the next page. It's actually on the back of yours. And it says, write the equation of the ellipse if the center is 3, -2, and the major axis is horizontal, which just means, hold on a minute, we didn't go over that. The longer one is called the major axis, okay? So in this case, the major axis is this one here, and it's a distance of 6. So 3 plus 3, right? And then the minor axis is the one that travels the horizontal direction, and it's 2 plus 2, which is 4. So you have to add those up to get the length of the major and the minor axis, okay? Any questions on that? Okay, then let's go back. It says the major axis is horizontal, so that means in the x direction, and has a length of 16. So if the whole thing has a length of 16, then from the center to each end has to be 8, right? And it says it's horizontal, so that's the x. So that means underneath your x minus h squared, you're going to have 8 squared. Okay, it says the minor axis is vertical, that's the y. So y minus k. And it says the length is 4. So if the whole length is 4, half of it is 2. So then under here, you're going to put 2 squared. And you know, these are always equal to 1. Now, I know HK. I could have gone ahead and just stuck that in. I just wanted you to concentrate on the bottom for a minute. So you're going to have x minus 3 squared over 64 plus, and you got y minus a -2, so plus 2 squared over 4 equals 1. Questions on how we got the equation? Now, if that's sort of confusing for you, but graphing is not, then it might help you just to graph it first and then go back and do the equation. You know, it might look more, and when you can see the picture, it might make more sense to you. So let's just pretend like we don't even have this yet, and we're going to graph it, and then you can see it that way too. So if the center is 3, -2, 1, 2, 3, 1, 2, that's the center. And the major axis is horizontal, so it's going this direction, right? And has a length of 16. So if the total length of 16, then it's got to be 8 here and 8 here, right? So 1, 2, 3, 4, 5, 6, 7. We're going to go out a little bit, aren't we? 1, 2, 3, 4, 5, 6, 7, 8. That gives me 16. Does everybody understand what I'm saying here? So this distance is 8, and this distance is 8, right? Any questions on that? Okay. Then it says that the minor axis is vertical, which is your y, and it has a length of 4. So 4 in this direction, so up 2 and down 2, and that will give you my total of 4. So 2 here and 2 here, right? And of course, you want to draw the ellipse. Okay, that center right there was 3, -2. So that goes here. I know that on the x direction, I'm going to take 8 and square it. And in the y direction, I'm going to take 2 and square it for my equation. So there it goes again. Don't understand that. So you see right here, I said sketch it first and then write the equation. right? Because I think most people probably think of it like that. I did it this way so you could see. Some of you will think this way. You could write the equation first and then sketch it, then write the equation. They have to go together, don't they? So when you get done, just make sure they do go together, right? Whichever one makes more sense to you first. Any questions on that? Okay, go to number 2, and you try it on your own. I'll give you a few minutes to work on that. Yes.
That was it comes on a vertical axis. This is 16 on a horizontal, but it still goes with it. Over the goes in that
If it's horizontal, it goes with X. X goes this way, and that's horizontal.
Yeah, okay. So it goes that way. Go on.
No, Y goes this way, that's vertical. You know, label your axes like this, will you?
Yeah.
You know, and that'll help you remember which one goes which way. So do y'all remember what the major axis means? It's just the longest one, right? It doesn't mean it has to be the X like in our other example. In fact, in this one, it's the Y, isn't it? Right? Because it says vertical. So Y is vertical, X is horizontal. And it looks like we're going to have to extend our graph out some, doesn't it? So on the major axis, it says it's vertical, it has a length of 16. So half of 16 is 8. So from the center, I need to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And I need to go down 8. So 1, 2, 3, 4, 5, 6, 7, 8. Now I started right here with the center at -1, 4. Everyone okay with their center plot? Any questions on just that much? Then it says the minor axis is horizontal and has a length of 9. Half of 9 is 4.5. So 1, 2, 3, 4.5. Then left, 1, 2, 3, 4.5. Okay, so now let me graph it. Now, let's look at this closely and make sure we've got this right. Okay? So this right here is 4.5. 1, 2, 3, 4.5. This right here, 1, 2, 3, 4.5, is 4.5. That adds up to 9. It's my x, isn't it? Right? So what I want to do, I know I'm going to have my center, which is -1, 4. I'm going to have x minus a -1 squared, and I'll have y minus 4 squared. Those are in the tops of the fractions. That's plus, and this is equal to 1, right? So underneath, this is the horizontal, so underneath the x, I'm going to have 4.5 squared. It's wanting to go off again, isn't it? I don't know. Now this right here is 8. This right here is 8. That gives me my 16. But under here, I'm going to put 8 squared. So this simplifies to x plus 1 squared. What is 4.5 squared? Okay, 20.25. And this is y minus 4 squared. What's 8 squared? Okay, equals 1. So I have graphed it, and this is the equation right here. I write the equation at the bottom just in case you needed more space here. But you can leave it up there. Those are a little bit tricky with the axis thing, you know? That's why sometimes it is better to just graph it first and then write it. I know. Because if it was written like this, you would take the square root of it, right? Yeah. Sometimes we're going backwards, you guys sort of go slower because your mind wants to jump back to what you were doing first, right? Okay, well that's all the notes we're going to take on that today. That finishes out the circle and ellipse stuff. Yes.